Hello all and welcome to today's video. So in this video, we will be covering the data flows in Data Factory. So till now in the Data Factory series, we have covered the all the basics of Data Factory, how to create different activities, how to create different components of Data Factory, how to use them, how to connect them with each other. So the complete playlist will be added in the description link below. So today we will be starting with data flows in Azure Data Factory. Okay, what are data flows? Data flows are basically graphical data transformation. In Data Factory, we have seen different activities which can be used for moving data from one place to another and can be used for only slight data transformation. Okay, but wherein we have data flows can be used for advanced level data transformation. So all the transformation that we do in SQL, in the same way we can do all the computation and transformation directly in data flows. So data flows they are fast. They are basically running on Spark clusters. So we have the Spark optimization and we have the power of parallelization over, and we also have the power of running parallel jobs over there. Okay, and the best part is we have a complete visual approach. So a person who is not having much knowledge with coding, they can also leverage the power of data flows. Okay, so moving ahead. So what are the use of data flows? As you can see these points, basically a person who is having the complete any knowledge of SQL, they can create with it. We can do any kind of aggregation, joins, select, union, filters. Okay, we can do null handling. We can derive some new columns. Okay, we can pivot and pivot data. So everything that you can think in SQL can be done in the data flows as well. So mapping data flow, what does a data flow basic structure looks like? So in a data flow, we should have we can have multiple data sources or a single data source, but we should have at least one data sink. So for example, if we are having multiple data sources and we are applying some transformation over here, okay, and for example, some filters and some sorting from data source 1, then from data source 2 we are getting some data and then joining it with the output of data source 1. Okay, and then we have it in our final I would say in final sync. Okay, so this is how data flow looks like. We can have multiple data sources, but at least one data sink should be there. So moving ahead, in the next, we will be seeing what is the so what are the working of data flow. As discussed, we have data sources, then we have transformation, and then if we have that data to some kind of I would say output store, okay, or apply any kind of other transformation, we can use that, and then at last we have the sink where the output is being done. So in data factory activities, same thing happened. We had some source data set and sink data set. So that was basically the copy activity, and in between, if we apply some other activities like filter or if we apply some kind of like lookup, so all these activity are basically just for moving data from one place to another. But in data flow, we can basically completely change our data based on our requirement. So let's head back to our data factory and see how data flow basically looks like. So in this section, factory resources on the left part, we see this data flow section. Okay. So if I go and click and create a new data flow, so this is a canvas where the complete data flow is created. On the right hand side, we have the data flow properties where we can rename, for example, demo1 data flow. And over here, you see there's a starting option to add a source. So first of all, we need to add a source, then only we can move ahead and do something else. So let's go and add a new source, and in the property panel below, we get the option to select our data sources. So for example, in the dataset section, I select the already created dataset. So I have this already created Azure SQL dataset, which points to a SQL table. Okay, so I've selected this dataset. Now this dataset can be used for the complete, I would say the complete uh, transformation that is going to happen. So we have multiple options. We'll be covering them one by one: source option, projection, optimize, inspect. But first of all, we will be focusing on this data preview. So what is data preview? So data preview is basically, as I told you earlier, the data flow works on Spark clusters. So if we are dealing with Spark clusters, in that case, what happens is, uh, so if we are dealing with, sorry, if we are dealing with Spark clusters, in that case, what happens is the complete data is not loaded in memory. Only a part of data, or I would say a snapshot is of data are loaded so that we can see what kind of data it is, and then we can apply the transformation. And when we run the whole application, then that set of transformation runs on the complete data set. For example, we are having some data in our source. Okay, so this is a source, and over here we have our data flow. So this data flow is running on some Spark cluster. Okay, so whenever we want to create this this data flow tries to access the data source. And for example, it fetches 1000 rows just for preview. It is not loading the complete data. It is loading a default 1000 rows so that we will be able to see what kind of data it is. Okay. So what kind of data it is, and then over this 1000 rows, we apply some XYZ transformation. Okay. So this transformation is applied, and then when we run the complete data flow, then the same transformation is now running on the complete data set, not only on the 1000 rows that we have seen for the preview. So this is where data flow debug comes in the role. Data flow debug, basically whenever we switch this on, so if we head back to data factory, there's an option we can basically switch this on. So it takes around 5 to 10 minutes to switch on. Till that, let's discuss what is basically data flow debug. So it's a live Spark cluster, okay, using which you can basically transform your data or debug your data for testing or development purpose. And this is charged on an hourly basis. So it's a live Spark cluster. So it will be charged based on how much you're using and for how many hours you're using. Okay, so what are different types of clusters runtime in ADF? So this Spark cluster is nothing but a Azure integration runtime, so which is running on multiple nodes. So we can basically leverage the default integration runtime created by Azure, or we can create a new integration runtime with the configuration required by us. Okay, so if we want some new integration runtime, we will head back to ADF. On the left pane, we have the manage section. In the manage section, let's go and create a new integration runtime. So when we click on create a new integration runtime, we basically want an Azure integration runtime, but with some new configuration. So in the integration runtime setup, on the right hand side, you see this data flow runtime. Over here, you can select small, medium, and large. So as we have seen in the presentation, small, medium, and large, they have the configuration of 4 plus 4 nodes, or 8 plus 8 nodes, or 16 plus 16 nodes. So we'll be discussing what these nodes are basically. But you can first of all like select it over here, or you can also go to custom and select the required set of, I would say, set of nodes based on your requirement. And in the custom tab, you also have the option to select general purpose and memory optimize. For example, you are dealing with a large data set, I would say 10 GB data set, which you think can't be basically accommodated inside a small cluster. For example, if your cluster is having only 16 GB of RAM each node, okay, so that will not be possible to, I would say, store the complete data if you're having TBs of data. So you can select memory optimized compute type. So memory optimized has more memory per node. So that will be sufficient for your heavy heavy in memory processing. Okay, so this is how we can create a new integration runtime. and then we can select it inside our data flow. So till our data flow debug is provisioning, we will go and discuss and see what our basically the cluster architecture looks like, so that it will be more clear to you.
First of all, for example, we have this driver node. So driver node is basically the entry point of our Spark application. So driver node is responsible for handling all the coordination or dividing the jobs and sending them to different nodes. Okay, so we have one driver node, and following which, for example, we are having I would say 4 different child nodes or the worker node. So we have these 4 different worker nodes, and each worker node are basically responsible for, I would say, uh, for the tasks that are being executed. Okay, and each worker node has their separate set of CPU cores and memory available. So for example, we have this worker node 1, 2, 3 and 4. So each will be having 16 GB of RAM, and sorry, so each will be having 16 GB of RAM, and for example, I would say 16 GB of RAM and 64 V-core CPU. Okay, so same will be applied for every of the workers. So 16 64 is the combination. Okay, so this is how the each worker node is having their own set of computation power. Now when the jobs are being sent to worker nodes, so each worker node has a set of, I would say, executors. Okay, which means where the actual jobs are running. So for example, each worker node are having 3 executors, which means where the actual job is running. Now how these executor basically executes a job. So these resources that we are talking about, these are being divided into each of the executors. Now for example, we are having an executor inside one of the worker node. So if one worker node is having 16 GB of RAM, so that 16 GB will be divided among the 3 executors, which means around 5 GB RAM or memory, and 64 divided by 3, which will be around 21. uh, this is for basically each of the executors. Now we are having 3 3 3 and 3, that is 12 executors in total, which means we can have, so if each executor is having 5 GB of memory and 24 vcore, so what is the total size or total capacity of our execution power? So we are having 12 executors, so 12 into 5 will be 60 GB or memory is the total memory of the complete cluster. And how many total vcores, which is 12 into 21, that is 252. Okay, so 252 vcore or CPU. So this is the complete computation power. Okay, so this is all about the executors. Now how does the job runs in our Spark cluster? So for example, we are having 252 vcores, which means the jobs are basically running on each executors. And if each executor is having 5 vcore, which means at a time one executor can run 5 parallel jobs. Okay, so if we are having 12 executors, okay, no. So for example, the jobs are being run on each one of executor, and if one executor is having basically 21 CPUs, which means in one executor 21 jobs can run in parallel. Okay, and if we have 12 executors, which means 12 into 21 will be 252 jobs can run parallelly in our cluster. Okay, so it is not always like the complete set of executors are assigned for only one application. Okay, and the set of memory that we are dealing with over here, that complete memory is also not assigned for the for our execution. This memory is basically divided into usable memory and caching memory. So there are multiple parts. We'll be discussing more in coming videos how memory are assigned. But taking as the true case scenario, we are, for example, we are having 60 GB of RAM. Now, for example, we our application has been assigned with 4 executors. Okay, which means 4 executors into 21 CPU, which is uh, 84 total jobs can run in parallel. Okay, so if our application needs 100 jobs to run, in that case what will happen, first this 84 jobs will run in parallel. Okay, and then rest of the 16 jobs will run in parallel. Okay, so this is how our jobs are being divided into our Spark cluster. So we have this driver node, we have the worker nodes. In worker nodes we are having these executors, and these executors is where the actual jobs are running. And these executors basically take the the complete resource available for a complete node. So this is a complete node. So the resource available to a complete node is being divided for each executors. Okay, so number of CPUs, total number of CPUs is the total number of parallel jobs we can run in a particular node or in a particular cluster. Hope this is clear. So this is how the cluster configuration works.
Now we have discussed, you have seen what a cluster architecture looks like. Now, when it comes to choosing the cluster size, it basically contains a n number of hit and trial methods plus n number of calculation by seeing the dataset size and by seeing the performance of the current nodes. Okay, so as it says, data flow distributed data processing over different nodes. As I explained you, whenever we have some jobs and are running on a Spark cluster, so it is divided into different nodes so that it can run in parallel. So increasing the size of cluster means increasing the size of node basically helps us to reduce the processing time. So for example, if we are having 20 different jobs and we are having only 4 vCores available, for example, we are having only one node available in which we are having 4 vCores available. So which means 4 different jobs can run at a time. So it will take around, I would say, 5 iteration to complete these 20 jobs. So what happens if we add a new node? A new node means more executors and more number of CPU. So in that case, our I would say few of the iteration uh, will will be removed and more number of jobs can run in parallel in one go. Okay? So for example, now we are having more nodes, so we'll be able to run 5 jobs at a time. So now we'll be having only 4 iterations, so less processing time. Okay, so I've already discussed the same in the cluster architecture. So this is how we can choose or increase the size of our cluster. Now, for example, if we are having more nodes than partition of data, for example, the partition of data or number of jobs are only 10, but we are having 20 nodes available. So okay, so which means adding more nodes will not be helpful to us because the time taken in each job is high. Okay, the parallel processing is more than enough to us because we have more than enough nodes available. So adding more nodes will not help us because all the jobs are running currently parallel, no jobs are pending. So Adding new nodes will not be helpful in that case, which means we need to go and optimize our current code, okay, so that the jobs running on each node as of now can be optimized and our overall processing time can decrease. So this is how we basically choose our, I would say, the nodes in the cluster. So data flow sources, data flow has a limited number of sources that it can support as of now. Few of them are mentioned over here, and few of them also mentioned in the link in the last point. So as the activities in Data Factory supports most uh, number of connectors out there, okay, all those connectors are not supported in the data flow. So they are limited. So but they are more than enough to capture most of the used data sources out there. Okay? So what all things we can do in data flow? We can join, we can split the data based on some condition. We can check whether a particular value exists or not, and then move our data or do transformation based on that. We can combine data using Boolean. We can basically do some lookup values. Lookup we have already discussed in the ADF activities part. The same way, other derived columns select, aggregate, means, sum, max, all those things, pivot and pivot data, filtering, sorting, all these things can be done using the data flows. So let's demonstrate how a data flow basically works. So I will head back to my uh, data flow. For example, over here, I have created a source over here. Okay, now this source needs to be connected to some of the uh, data set. Okay, so I have assigned a Azure SQL data set over here. Okay, so now this Azure SQL data set basically points to a table in my Azure SQL DB. So my data flow debug is now on. So let's see what kind of data is available in the data preview. So if I go and refresh the data, so it is asking me for a parameter because my data set is having a parameter. Okay, so I have a table uh, which I will be using. Let's go and check that table. So I have this table daily stocks data. So I will be using that. Okay, so now save and it will start refreshing or fetching the data present in our actual table. Okay, so now we can see the data has been fetched over here. Now, how many rows will be fetched over here depends upon our debug cluster settings. So at the top, we have this debug settings. Over here, see this row limit. So at a time, only 1,000 rows will be fetched for preview. So we can change it based on our requirement. So we have fetched those rows present in the table. Now let's see what all properties are available in our data flow sources. So first in the source setting, we have this option. So allow schema drift. Allow schema drift means whenever there's some change in the schema of the actual table, if we add some column or remove some column in the tables, so in our database, that will be directly captured in our data flow. If we don't want that, if we want the number of rows that have been fetched now, for example, if you have fetched 5 rows, and if you want to remain that for the complete life cycle, we can uncheck this allow schema drift. And same in for drifted column types, which means the new columns that are being fetched, do we want to select it or infer the data type for that? If we want that as well, we can select it in the section over here. On the source option, we are getting the data using the table. So table is selected. In the projections, projection means what kind of data type we are going to deal or what all columns we are basically dealing with. So if we want to use these values in or use these columns for some transformation in the next step, so we need to import the predictions so that we could have the total number of columns assigned in our sources. Okay. So in optimize, we can see what kind of partition we need to follow. So if your table is having some kind of partition, you can use the current partitioning, or you can basically set the partitioning required by you. Either hash dynamic range fixed range of partitioning, or you can also partition using some partition column. So if you select the source tab in the partition column, you can select which column based on which column you want to apply the partition. So as of now, I will use the current partitioning. Okay, so this is all about the uh, I would say data source settings. Now let's apply some transformation. So when I click this small plus sign, I will be able to see all the transformation that are available over here. Now, for example, if I go and select, I want to filter out some value. So I will go and select a filter option. So now in the filter option, I need to give some condition. Okay, so what condition can I give over here? I want to select only those value where the stock symbol is for, I would say, Microsoft. So let's see our data. The complete data flow works on expressions. So whenever in any page where you want to give your condition or give user input uh, to say data flow what they want, you have this expression builder. So if I open this expression builder, this kind of expression builder basically opens where you can write your conditions. So in this condition, you can use n number of data types, data variables, functions. But as of now, I need to deal with our columns which are present in the table. So for that, you can select the column name over here. That is stock symbol, company name. So these 5 columns that you see over here are coming from the data source. I can filter it out using the input schema. If I click on input schema, which means what is my input, based on that I'm getting 5 columns. Okay, so if I select stock symbol and I want stock symbol equal to MSFT. Okay, so all the arithmetic of operators, logical operators are present over here in the below tab. So plus addition, subtraction, then we have the comparison, equal to, greater than equal to, less than equal to. So all these are available options over here. So as of now, I want to compare it with the MSFT stock symbol. So I've added this expression and let's check, save and finish. So as I told, in data flow, what you can do is at every step, you can see what's the output you are expecting after that transformation. So in the filter tab, if I go to data preview and refresh it, it will give me the output based on what conditions I have in the filter. So if I refresh it, it will give me all the values where stock symbol is MSFT. Okay. So at each step, you can preview what's the output you're expecting. Now let's write this data to our sink. So when we click on this plus sign, we need to select a sink. And in the sink tab, I need to select the data set where I want to write it. So I will write it in one of my, I would say, data lake storage. So I've selected the data lake storage. So let's keep everything by default as of now. Now let's run the complete data flow. Now how this data flow runs? Data flow basically runs through a pipeline. So I have, for example, a pipeline. So this is a pipeline. In this pipeline, I will run the complete data flow. So as we have activities in pipeline, like for each lookup and all those things, in the same way we have a data flow activity. So for example, I have created this data flow, which is demo1. Okay, so which is pointing to my demo1 data flow. So I can run this data flow using the pipeline, which is using the data flow activity. So I will head back to my pipeline, create a new pipeline, and in this I will select the activities, which is data flow. So in the data flow, I will select the data flow name which I want to run. Now see, when you select this data flow one, it will ask you for all the parameters. Why? Because in demo1, my source and sink, the data set which are used over here. So if you see this data set ls Azure DB, and in the sink the screener underscore ADLS, all these data sets are taking some parameters. If I click on open, you'll see these are taking some parameters. So whenever I try to run this data flow using a pipeline, it will ask for a parameter. So I will assign the parameter values, and let's write msft.csv. Okay, so it should run on the integration runtime, the default one which is selected. Compute size, I can select the compute size that I want for this particular data flow. So let's keep everything default and let's debug it. So when we debug it, what it does is it triggers that data flow. So you see at the bottom, the data flow is being triggered from here. And if you want to monitor, you can click on this inspect button and it will take you to the live monitoring of this data flow. So let's click on refresh and see what steps are being performed. Now you see the sync one has succeeded, which means my data has been written to my data lake storage. Let's head back to my data lake storage and see what kind of data has been written. So in the stock data container, you see there are some files, but for today, a file has been written over here, which is 11th of August, 10 a.m. So why we basically see this part -00, because whenever we dump data to a CSV file or any kind of data in our data lake storage, that is basically dumped in partitions. Okay, that's why we are able to see this kind of naming convention. So either you can save this value directly in some MSFT folder so that you can fetch it easily, or you can directly use the CSV file for your computation. Okay, so that's how our data flow basically works. So we create some data sources, we have some transformations, and then we apply or run that particular data flow using our pipelines. So it is always recommended to disable this data flow debug when your work is finished, so that you will not be charged for the Spark clusters during a time you're not using it. Okay. So that's it for today's video. Thank you so much. Do like, share, or subscribe the channel if you find this video useful. The part 2 of data flow, where we'll be uh, diving more deep in the transformations of data flow. Okay, that will be uploaded as part 2. So stay tuned. Thank you so much.